Hello and welcome to the ICS 103 programming course. This is the fourth lecture in which we are going to be talking about data types, operators, and expression. Okay, so let's start. So the first thing is we're going to give an outline. Okay, so here are the outlines of the program or the material that we're going to cover. We're going to talk about C arithmetic expression, operators, data types, mixed data types, and assignment, C-type conversion, expressions with multiple operators, writing mathematics formulas, and formatting and styling. Okay, so this is basically what we will cover in this slides. Okay, so first of all, let's talk about why arithmetic operations. To solve most programming problems, you will need to write arithmetic expressions. Okay, these arithmetic expressions are used to manipulate variables such as double, integer, and the next slide shows all arithmetic operators. Each operator manipulates two operands. Okay, so there are two operands that it takes. What are an operand? Are the two things that it actually works on. This is called an operand. So for example, 5 plus 2, 5 is an operand, 2 is an operand. So all the mathematical operations take two operands, the first operand, the second operand, and they perform a certain operation. The addition sign over here takes two operands, the 5 and the 2, and actually adds the two numbers together and produces in the output. Okay, now the operands could be a constant, could be a variable, could be an arithmetic expression. An example of a constant is 5 plus 2. Variables could be sum plus another variable I and CR multiplied by 2. So, and this is an expression. So this is a variable and an expression. This is an expression and expression. So you add two expressions where B divided by C are two variables. Okay, so it could be anything, a variable, an expression, or anything else for that matter. So here are the arithmetic operators. There's an addition for double and integer. There's a subtraction for integer and double, and this is how you write the addition. 5 plus 2 is 7. 5.0 plus 2.0 is 7.0. So integer division and double integer addition and double addition. And then you have the subtraction where 5 minus 2 is 3, 5.0 minus 2.0 is 3.0. Then you have the multiplication where 5 multiplied by 2 is 10 and 5.0 multiplied by 2.0 is 10.0. Don't forget the decimal part in. And then the division, which is denoted by the slash sign for the integer and double. For an integer, 5 divided by 2 is 2, and the 5.0 divided by 2.0 is 2.5. In an integer division, please note that there is no decimal point, so you only give the whole part out. So 5 divided by 2 is 2, and you disregard anything that is in the decimal point. This is the modulo sign or the remainder sign, the percentage, we use it for it. So 5 remainder of 2 is 1. This is for integer numbers only, and it only it's the remainder. When dividing 5 by 2, you get a remainder 1. The remainder should always be less than the divisor. If you have a number that is larger, then you have a problem, and we'll talk a bit more in the next slide on this. So these are the basic mathematical operations that you can do in C. Okay, so let's talk about division. When applied to two positive integers, the division operator, which is the slash sign, computes the integral part of the result by dividing the first operands by its second. Okay, so example, 7.0 divided by 2.0 is 3.5. However, 7 divided by 2 is 3 only. The reason for this is that C makes the answer to be same type of the operand. So 7 and 2 over here are integers. So when you divide integer by integer, you get an integer output. And then 7.0 divided by 2.0, these are over here are double variables, and when you divide them together, you get a double variable as 3.5. Now, how does the division actually occur? This is pretty simple. 7 divided by 2.0, so this should be a 7.0 actually. So this example is the same. So you multiply this by 3, you get a 6. You subtract 6 from 7, you get a 1, and then you raise the decimal point, get a 0 down, and then you multiply 5 by 2, and you get 10, and you get the remainder is 0. Whereas in integer division, you do 2 divided by 7, so you multiply by 3, you get a remainder of 1. Now this is not divisible by 2, so we stop and we say that the output is 3. So 2 divided by 7 is 3, and we discard the remainder part. Okay, this is how the division operation goes. Now the remainder operator returns the integer remainder of the result of division of its first operand by second. So 7 remainder of 2 is 1, 6 remainder of 3 is 0. Why? Because 6 is completely divisible by 3. The value of m remainder n must always be less than the divisor n. Okay, very important. So this is actually the remainder. So when you do a division, whatever is over here left, which cannot be divided onto the divisor, is called the remainder. So data types and expressions. Okay, so over here what we're saying is that the data type of each variable must be specified in the declaration. Okay, so this is well known, but the question then becomes is, how does C determine the type of an expression? Okay, so if we have an expression, we have multiple variables, how does C determine the type of an expression? Example, if we had an expression x plus y, when both x and y are of type integer, what is the result of x plus y? Okay, that is the question that we are basically asking here. So x plus y, if both x and y are integer, the answer is the result will be an integer because both operands are integer, so the result should be the integer. Okay, the data type of an expression depends on the types of its operands. If both are of integer, then the expression of type integer. So you do an integer addition if x and y are integer. If both are doubles, suppose x is double, y is a double, and both of them will be a double, and you will get a double output. If either or both of the types are double, then the expression is of type double. Okay, so if one of them was of type double and one of them type integer, what is going to happen? The compiler cannot add an integer with a double. Okay, so if you have a double and integer, they cannot be added. So what it'll do, it will raise the lower type to a higher type, so the integer type will be raised to a double since the integer is lower than the double, and then a double addition is going to take place, x plus y, and then it's going to actually assign the value output as a double. Okay, so as always, the integer risen to the double. Okay, an expression that has operands of both integer and double are called the mixed type expressions. Okay, so anything that has multiple types of operands, it's called a mixed type expression. Okay, now the expression being evaluated and the variable to which it's assigned to have different types. What happens in this case? So what we're saying over here, basically, if we have 5 divided by 2 and we assign it to a variable y, where y is a double. So 5 is an integer, 2 is an integer, you divide 5 by 2, you get an integer value. So 5 divided by 2 is 3. Oh, sorry, 5 divided by 2 is 2. So you get a 2 as a result, and then you have to assign it to y. But y is a type of a double, so how would we assign an integer variable to a double? We have to raise the integer to a double, so the 2 will be raised to 2.0 and y will become 2.0. Okay, don't mistake it to be 2.5 because y is a double, because the division over here is going to an integer. So first, so rule number 1 is divide, you get 2, then assign, you get 2.0. Okay, so here's how it's going. 5 divided by 2 is 2, and then you want to assign the output to y, so it becomes 2.0 because y is double. If y was an integer, fine, the result of an integer will become 2. When assignment statement is executed, the expression of the first evaluated, then the result is assigned to the variable left side of the operator. Okay, so warning. The assignment of type double expression to a type integer variable causes the fraction part of the expression to be lost. Okay, what if I had y as an integer and I had a 5.0 divided by 2.0? Sorry. So 5.0 divided by 2.0 results in 2.5. Now I have to assign it to y, but y is an integer. So the result of this is 2.5. Now I have to take this and assign it to y. And when I assign it to y, y is an integer, so what do I have to bring? Bring your scissors and you cut it from here. So you get a 2, you assign the 2 to the variable y. So then y has the variable, the output of this is y is equal to 2. Okay, so this is because y is an integer, you're going to delete the decimal part, or you're going to omit it out, because that is what casting does. Okay, so here's The example of a double assigned to an integer. Type conversion, so this is just a revision. C allows the program to convert data types from an expression. This is done by placing a desired type in parentheses before the expression. Okay, so this is where you're telling a compiler explicitly what you should think of this number. So example, when you say double 5 divided by double 2, you're asking the compiler to take 2, convert it to a double, take 5, convert it to a double. When you finish converting the to double, it becomes 5.0 and 2.0. Do a division, so there's a double division. So that's 5.0 divided by 2.0, it will become 2.5. Okay. On the other hand, you can also define 3.0 divided by 2.0 and put integer in brackets in between them. What you're telling is typecasting over here. You're telling the compiler, take the 3.0, this is a double number, but put it as an integer, divide it with an integer of 2.0. So it's 3 divided by 2, and the value will become 1. Okay, when casting double to integer, this whole part is just truncated. You just bring the scissors and cut it out. That's what I say to my students. Okay, do not round. Now here is an example, and I do apologize, this color is not good enough. Next time I'm going to change the color. So in this one we want to compute a test average, and how to compute a test average? We add the grades together and we divide by the total number of students. So in our main function we have an int total score num students and double average. Okay, so we ask the user, we prompt the user to enter the number of the sum of the student's score. So he's going to enter the sum, and we read that sum from the user, and then we ask the user to enter the number of students, and we read the number of students from the user. Now notice that we made the number of students to be an integer because we cannot have 1.5 student in a class. Okay, so the number of students has to be an integer, and we made the total score an integer because we're assuming over here that the scores do not have fraction parts in them. So I give you from the beginning of the class that okay, the total score will never have, or you will never get a fraction score, you will always have integer grade. That is why we're getting the grade into an integer variable. Okay, so now we have to calculate the average, and I do apologize over here. This is written average equals to, and between brackets, double total score divided by double num students. Okay, so I'm taking actually the number of students over here, which the user entered over here, and asking the compiler to convert it to a double. So whatever the user entered over here, suppose the number of students is 50, I'm going to take the number of students and make it 50.0. Okay, and suppose the total score is 500, so I'm going to take 500, and using this double I'm going to convert it to 500.0. So 500.0 divided by 50.0, you get the average score, and then you can actually print out the average. So what happens over here? Let's take it in details. So this is my main program, and this is my main. So whenever I run this program, I'll have a main and I'll have a memory allocated to my main. Okay, inside this memory I'm declaring total score, and it has a location. We'll store the variable, and the num student, num student, and I have a variable for that, and I have an average, and I have a location to store the average. Okay, so this is an integer, and a double. So the integer takes 4, and a double is 8 byte. And when I actually read the input from the user and I say scanf %d, the address of the score, address of total score, I'm actually entering the number over here. So the total score, what's the total score? Suppose we have 500 as our total score. So I'm going to take an integer number, and I'm using %d, and read it and insert it into an integer variable. So I'm going to have exactly 500 inside it, and then I'm going to prompt the user to enter the number of students. Suppose that he enters 50. So I'm going to take the 50 and put it inside my num of students. In this I'm saying average double total score divided by double num students. When I say double num students, what I'm telling the compiler, please go to the num students, take the value 50, take it out, convert it to a double, it becomes 50.0, and take the value of 500. Okay, so that's the total score. Convert it to a double, that becomes 500.0. Divide them together, but do not change the variables for me. So the variables will stay as integer. What you're doing is at the runtime, you're telling it to take the number and treat it as a double. So this will become 50.0, and this will become 500.0, and you'll divide it, and you will get the average as the output. So the average would be 500 divided by 50 at 10. Okay, So this is what's going on, and then you have to print it, and we'll have a return 0. Okay. Operators can be split into two types, unary and binary. What is a unary operator? A unary operator takes only one and only one operand, okay? Just like a negation. When you write, in mathematics, we write minus x, okay? When we write minus x, we mean take the value of x and negate it. This is a unary operator. A binary operator, such as the addition, subtraction, the multiplication, division, modulus, and all the other operators that we know. An expression such as this can have unary as well as binary operators. Unary operators are just like the -5, and the rest over here are the binary operators. Okay? So how do we evaluate an expression such as this in C, which has unary and which has binary? So here are the rules for evaluating an expression. The rule number 1, okay, so I'm going to write 1 over here, is parentheses rule. All expressions in parentheses must be evaluated separately. Okay, so you first start with the parentheses, you evaluate each parentheses separately. Nested parentheses expression must be evaluated from inside out. So you take the inner parentheses and then go out till the outside parentheses, okay, or the brackets. With the innermost expression evaluated first, okay? So this is the first rule. Rule 2 is the operator precedence rule takes place. Multiple operations in the same expression are evaluated in the following order. First, you do the unary. Okay, so this is rule 2, and this is A of rule 2, which is a unary. So you first do the unary, then B, you do the multiplication, division, and modulus, then C, you do the binary addition, subtraction, and then rule C, which is number 3, is the associativity rule, where you use unary operators in the same subsequence and the same precedence level are evaluated right to left. This is very important, right to left. So you evaluate unary from right to left, and associative rule. And binary operators have the same expression and the same precedence level are evaluated from left to right. So this is from left to right, whereas the unary, this one is from right to left, this is from left to right. So I'm going to write an arrow here. This is right to left, and this is left to right. Okay, and it's going to become clear in the next example that we're going to take. So here's a table that actually summarizes things for you. So this is the highest priority. Expressions and function calls. Expressions between parentheses are the first thing that are evaluated, and function calls are the first thing evaluated. They're evaluated precedence takes from left to right. Then you have the unary and the typecast, which is right to left. Then you have the binary operation, multiplication, division, and modulus, which takes left to right. Binary addition, binary subtraction, left to right, and equal to sign is always assigning from the right hand side to the left hand side. And here is an example. Okay, the example is y, as we have an integer a, 3, b is equal to 5, c equals to 2, and a double y, and we say y is equal to double minus 3 divided by b plus a multiplied by b minus c multiplied by a. So the first thing we are going to look at are, do we have expressions in parentheses? We don't have any parentheses over here. Do not be confused. This is not a parentheses, this is a typecast. Okay, so this is one operation. So we don't have parentheses, so we jump we jump to the next operation, whereas the unary addition, unary subtraction, and typecast. So we come and look at the expression. We start from the right to left. Is this a unary? No, this is not a unary. This is a binary. This is a binary. This is a binary. The first unary we encounter is this one, minus 3. So minus 3 becomes minus 3. Okay, and the difference is this minus 3 is written minus, and the value of your number is 3. After evaluating this minus 3, the value of your number will become minus 3. Okay, so this is a difference. This is minus 3. Okay, so evaluate this first. After we evaluate this, what do? We look at this double, which is another unary typecast, and the minus 3 becomes minus 3.0. Okay, so this is the second operation that occurs. So the first operation and the second operation. Then we find that our unary is finished. Then we go to the binary operations, which is the multiplication, division, and modulus, and we take it left to right. So the first is the minus 3.0, which we have, divided by b. Okay, so we take the value of b, 5, and we divide minus 3.0 by 5. This is the third operation that we do. Then the next operation we do we leave the binary addition because the order of precedence is lower. We still have multiplication, so we multiply a by b, and that's the fourth operation that we do. We leave the subtraction because we have a multiplication which has a higher order of precedence, so we multiply c by a, and we multiply it by c by a. This is the fifth operation. Then the sixth operation will be the addition, and we go left to right from the addition, so the addition goes before the subtraction. So the result of this plus the result of this will be added together, and then the result of this will be subtracted from this, and that is your seventh operation. And the last operation is the assignment operation, where we actually assign the operator to the value to y. Okay, so the operation, the whole expression is evaluated, and the value is then assigned to the variable y. Okay, so this is one of the examples. Another example that we're going to show over here is if you want to calculate the area, which is pi multiplied by radius multiplied by radius, or r square, and you write the expression area is equal to pi multiplied by radius multiplied by radius. You're going to, first of all, since all of them are the same level of precedence, so both of them are multiplication, you're going to multiply the pi by the radius. This is the first operation. Then the second operation is that you multiply the result of this by the radius again, and you get the area. Okay, and this is what we call the evaluation tree. You can see the tree is starting. At the end you will have only one output, but you might have different, and the tree actually starts branching and branching. If you had a bigger expression, it's going to start branching and branching more and more until you reach the output of the final result. Okay, now here's an example. If we have z minus between bracket a plus b divided by 2 close bracket plus w multiplied by minus y, how is he going to evaluate it? Okay, so the first thing it's going to look at, this is your expression, it has parentheses, so it's going to evaluate the parentheses first. So there's an expression here, a plus b divided by 2. In this, b divided by 2 takes precedence over the addition, so you divide b divided by 2, and you get, this is the first operation that you do. Then you do the addition with a, and this is the second operation that you do, so you completed evaluating the parentheses. Now you go back to the order of precedence. What is the first thing that you evaluate? Is the unary sign. So you look at it, you have minus y, so you go and evaluate this as the third operation that you do. Minus y becomes minus y. Okay, so the value of y is negated, and that's the third operation. And after that you look at the order of precedence. You have the multiplication sign, which is the highest from the plus and the minus, so you do the multiplication. That's your fourth operation that you do. And the fifth operation is then z minus the result of this, so z minus the result of the fifth operation. And the sixth operation will be the addition, and you do the addition of the entire of this expression with this expression, and you get the result. Okay, so this is how it goes. Now let's take examples in numbers and see how it goes. So suppose z is 8, a is 3, b is 9, w is 2, and y is minus 5, and I have the same expression which I talked to you last time, z minus a plus b divided by 2 plus w multiplied by minus y. So I'm going to replace the variables by the numbers that I have actually discussed over here. So z with 8, y with minus 5, and all the other variables. So we start. The first thing we do is the division. So 9 divided by 2, this is an integer division. 9 divided by 2 is 4. Okay, no decimal points. And then we add 3 into it, so it becomes a 7. Okay, so we have to evaluate the parentheses first. So we finished evaluating parentheses. What's the order of precedence? It's the negation. So we negate whatever is in y. What's in y? Minus 5. If we negate it, it becomes 5. Okay, then what happens is that we have this expression, and then we have to do the multiplication. So we multiply and we get a 10. Then we have this expression, and this has the same preference, so we go to the left and we start evaluating it. So 8 minus 7 is 1, and then we have to add 10 into it, and we get an 11. Okay, so this is an example of how you do an evaluation tree. Don't go and do other things. Don't multiply. For example, don't multiply y by minus w first, and then go add a plus b, and then divide by 2. Okay, so you do a plus b divided by 2. That's going to result not in 7. It's going to result a is 3 plus b is 9. That is 12 divided by 2 is going to result with a 6 in this. Okay, which is not correct answer. The correct answer, the compiler is going to take b divided by 2 and then add a to it. Okay, so make sure that you follow the precedence rules in the evaluation of an expression. Okay. Now, writing mathematical formulas. When you write mathematical formulas, you might encounter two problems in writing it. Okay, the first, Multiplication often can be implied in formulas by writing two letters to be multiplied next to each other. Okay, so in math we do write 2a, for example. If we write 2a in math, that is equivalent of writing 2a in math is equal to 2 actually multiplied by a. In C, you have to write it explicitly 2 multiplied by a, because 2a, it will think it's a variable name, and then the variable name cannot have a 2, it's going to generate an error for you. Okay, so this is not permissible in C, whereas this is permissible in C. The second area where your problem might be is in the order of precedence. As a plus b divided by c plus d, do not write this. This is not equivalent to a plus b divided c plus d, which is equivalent to a plus b over c divided by d. So this is not equivalent to this, but equivalent to this. If you want to write this, this is what is equivalent to it. So you write a plus b divided by c plus d. Okay, put the brackets so you give the order of precedence to the compiler. Okay, so writing mathematical expressions, be extra careful on what to divide and what to add. Okay, and use parentheses to help you in that. Now, programming styles. Why we need to follow a convention. A program that looks good is easier to read. That's very important. Okay, if you're submitting your homework, or if you're doing something you want, or you're submitting your code to the company that you're working for, you want the person you're submitting your code to understand it so he can actually debug it or test it easily. Okay, it's more easier to read than understand sloppy codes. 80% of the life cost of a piece of a software goes in maintenance. Okay, and you can actually get that. We usually get, for the operating systems that we have, we usually get constant updates, and we have to update our software so that we can actually avoid any problems in the software. So 80%, imagine 80% of the life of a piece of a software goes into maintenance. Okay, so actually coding and making it only is 20%. So writing an easier code to read for the people who are doing the maintenance for the 80% of the life of a software, which might be 10 years, is going to be something very highly recommendable. Hardly any software is maintained for its whole life by the original author. Okay, usually you'll make a code and then you'll find a good job because you're a good programmer, and you'll move on to another company. So your code will be inherited by someone else, or worst case, you might inherit a code of someone who has written it. Okay, someone else written it and you'll inherit it. You'll get employed in a company as a fresh graduate, and they give you the code and say, okay, go ahead, work with this code. Okay, so you will get code from other people, so you would like them to actually have written a code which is easier to read. Programs that follow typical conventions are more readable and allow engineers to understand the code more quickly and thoroughly. Check your textbook as some useful links. So there are useful links in your textbook. Please go read your textbook and get directions on how to write code very neatly. Okay, now the compiler ignores extra blanks. So this is the bottom line. Extra blanks are ignored between words and symbols, but may insert space to improve readability and style of the program. So whenever you're doing addition, subtraction, or any binary operation, please do put a space between the operation and the variable, and even between the equal sign and all the other stuff. And you should indent your code. Indent your code is actually tab it, and I'm going to have an example in the next page. I'm going to show you how you indent your code. Okay, so this is a bad program, and I'm going to just write on top of it bad. Okay, so you can actually see it. So this is a bad program. This is an int main void, int foo blah scanf, and it's actually, this is a very bad code, whereas the same code written over here is written over here, which is a good code. And you can see you have the int main void, and you have the function. This is the same function written over here. Each instruction is written on a line. It's written very neatly. You see the indentation that he has left in this program, that showing that the main function starts from here, ends from here, and all of this is indented because I know that this is inside my, so I can actually immediately by looking at it, I know that this is inside my main function. Only one instruction at a time in a line, because extra spaces, he has put extra spaces over here, so it's more readable, whereas no spaces over here makes it a tougher reading for the user. Okay, so this is a good example, this is a bad example. Other styles. Properly comment your code. So please comment your code when you write code. Please comment it. Give variable names meaningful name. Do not give XYZ. Give it speed, area, whatever name that you like, but a name that is descriptive. Prompt the user when you want to input data. Don't leave a blank screen to the user. Ask him what you want to enter so that the user knows what he has to enter. Display things in a way that looks good. Use tables, formatting, spaces, tabs. Insert new lines to make your information more readable. So insert the new line character, the slash n in printf. Format numbers in a way that makes sense for the application. Okay, so if you're using a bank application, don't go more than 2 decimal points in displaying your bank account. If you display 10 decimal points, the decimal points at the end are of no significance for me. I only have 2 decimal points that I have to display. Okay, so display it in a way that makes sense. Bad programming habits is missing statement of purpose. You do not write a comment of what's the purpose of your statement. Inadequate commenting. So you have a code, so imagine 10,000 lines of code and it's not commented. Variable names are not meaningful. So you have all the variables X, Y, Z and you don't know what's going on. So you have to really dig into the code and understand what's he doing and then get the mathematical formulas out and then determine what he's doing. Use of unnamed constants. Okay, don't use constants with a name. Indentation does not represent program structure, or you do indentation that is not in the program structure. So you don't indent the functions that are inside them, you indent the main function itself and you put everything out. Indentation is not correct. Algorithm is inefficient or difficult to follow. Okay, so don't make inefficient algorithms or algorithms that are difficult. Make efficient algorithms and that are simple. Okay, program does not compile. This is a very bad program that doesn't compile. However, a worse program than a program that doesn't compile is a program that produces incorrect result. It compiles fine but produces the wrong results. Okay, this is even a worse program. Okay, insufficient testing. You have to test your code very thoroughly because testing gives you confidence that your code is good and it's working and it's not producing incorrect results. Okay, by the way, testing sometimes take 30% time off a programmer, so do not underestimate the testing. Okay, so when you see software development, these are all the things that you have to do, so don't underestimate what the software developers are doing. Okay, and with this we come to the end of our lecture. I hope you enjoyed the lecture and hopefully see you next time.